Hello everyone, welcome back to my YouTube channel, The Blazing Sun. Today we are in the seventh session of our complete Python fundamentals from basics to advanced course. And today we are going to learn a lot of stuff regarding the jump statements in Python. So let's get started. So before starting today's session, I gave you two homework questions in the previous session. First we will discuss those questions, then I will move to today's topics. So discussing the first question first. So the first question is, you have to take a number as input and count its number of digits. Let's say the number is 1, 2, 3, 4. You have to count the number of digits and you have to return 4. So discussing the first question, solution of the first question. So let's say the number is num. I will take the number as an input from the user. Okay, I have taken the number as input from the user. You remember in our previous session we did a question in which we had to print the digits of a number in reverse. Let's say the number was 1, 2, 3, 4. We had to print 4, 3, 2, 1. So we will basically use the same logic in this particular question as well. Just there is a small difference in this question. In the previous question, we had to generate all the digits of that particular number. But in this question, we have to just not generate the digits, but we have to just count them. So this question is little bit more easier than that question. So how we will do that? Let's see. Suppose the number is 1, 2, 3, 4. Let me take this example. Okay. So in the previous session, we learned that how will we get 4? We can do 1, 2, 3, 4 modulo 10 and we will get 4. I hope you are following these sessions in the sequence in which they are given. So yeah, 1, 2, 3, 4 modulo 10 will be 4. Then what you will do is you will basically perform an integer division of 1, 2, 3, 4 by 10. So you will get 123. Now in the next step, you will take 123, then you will uh, calculate its remainder. You will get a 3 uh, like this. Uh, yeah. Then you will again divide 123 what by 10 in the form of an integer. You will get an answer which would be let's say 12. Then you will calculate 12's remainder when divided by 10. You will get 2. Uh, Now you will divide 12 by 10 and get an integer division answer as 1. Now you will calculate 1 modulo 10. You will get an answer as 1. Okay, so this is basically how everything will happen. And at the end, you will, to terminate the loop, or basically to be sure that we have got all the digits and no digit is left, you will again divide this particular one, this one, by 10. So you will get 0. Note that we are performing the integer division. So this is how it will happen. And you will get your digits over here 4, 3, 2, and this 1. So this was how you will get all the digits. But in this question, you can see They have not asked me to basically get the digits. They have just asked me to count those digits. So can we say that the number of times we can divide a particular number or perform an integer division by a number, that is also the number of times we are basically generating a number, a digit, or we are basically getting a particular digit. So first time I got 4, at that same time I divided that particular number 1, 2, 3, 4 by 10. The next time I got 3, at the same time I divided the number as well. So we can say if I do not want to get that digit of a number, I can easily skip the process of getting a particular digit and just keep on dividing the number by 10 uh, in the form of an integer division, not in the form of a float division. So what I mean to say is, I'm taking the same example, 1, 2, 3, 4. What I mean to say is, first if I will do 1, 2, 3, 4 integer division by 10, let's say I will get some value, and that basically the value will be 123. Again, I will perform an integer division, 123 integer division by 10. I will get a value of 12. Now again, I will do 123 not 123, basically 12 integer division by 10. So I will get a value of 1. Again, I will do an integer division by 10. So basically I will get 0. So you can see I did the integer division till my number became 0. So how do I count the number of digits? Basically, we know that the number of digits are equal to the number of times I have divided that particular number by 10 in the form of an integer division. So what I can do is, at the starting, I can declare or I can assign a variable, let's say it is called count, and I can initialize it to 0. What I can do is, each time I am dividing that particular number by 10, I can just keep on increasing the count by 1. So what will happen is, the number of times I am dividing that number by 10, I will get that number of times basically as a value in the count variable. So what will happen is, count will become 1 over here. Next time I will increase count again by 1. So it will become 2 over here. Next time I increase the count again over here, I will get count over 3. Next time I will get a count, I will get a value of 4. So this is how I basically get all the digits, not the digits, the number of digits a particular number has. So writing this in a form of code. So you have taken the number as an input. Let's say I am taking a variable count, which will basically store the number of digits that a particular number has. So count is actually equals to 0 initially. Now do note that this logic is valid, will give an answer only if the number is not 0. So we need to also give one condition, that if number is actually equals to 0, I will print one digit, because the number of digits in 0 is 1. 1 digit. Or yeah, you can do this like this, or you can give a condition that if number is equals to 0, count is equals to 1. and at the end of the program you can print. Or yeah, you can even do like this. Now what I will do is I will write while num is greater than 0. So each time I am performing an integer division of the number by 10, I will also increment the value of count by 1. So I can do like this. Num is equals to num integer divided by 10, and count is equals to count plus 1. I could have also done other thing, which I am telling you here. I could have written count plus is equals to 1, and I could have written num integer divided by equal to 10. So this was also a thing that I could write. Uh, these are just comments. So yeah, these are the things that you could have written. If you have seen my session of the assignment operators, you will easily understand that how we can write these things like this, or even these things are correct. There is no issue. So I'm seeing that I am keeping on dividing number by 10, and I'm also uh, counting the number of digits. So at the end, I can print count digits. So I can print that these number of digits the particular number has. So now I'm going to code this particular example. Let's say my file's name is number of digits HW because it was a homework. So let's say I am taking the number as an input. I am telling the user enter a number. I am saying if num is equals to 0, make count equals to 1. Otherwise, uh, you can also write else, but yeah, basically you can write an else over here. Otherwise, if num is not equals to 0, count will be equals to 0. And in else, you will start calculating, or no need to write the code in else, while uh, num is greater than 0. See, why I did not write this while loop in else is because if the number is 0, this while num is greater than 0, will this particular loop will never get executed. This is because if the number is 0, and we know that 0 is not greater than 0, so this particular condition given in the while loop will be false always. So what I will do is I will say I will do num equals to num integer divided by 10, or I could have written num integer divided by 10, integer divided by equal to 10. Count is equals to count plus 1, or I could have written count plus equals to 1. Now what I will do at the end of this loop, I will write print statement outside this loop, and I will write uh, let's say how many digits the particular number has. So the count variable is storing that. So I will give the output as like this. Now I'm going to run this particular code for you. Let's say our number is 0. So it is printing 1 digits, or 1 digit basically. That's not an issue. Let's say our number is 12045. So you can see 5 digits. Let's say our number is the same that we took our example as 1234. You can see the output is 4 digits. So yeah, our code is working correctly. Now moving on to the second homework question. Uh, you have to take a number as input from the user and reverse the number. Now, to reverse the number, what I mean to say in this is a little bit trickier question. So to reverse a number, you also need to get the digits. Why? Let me tell you. So this is the solution to the solution of the second question. Now let's think about the logic of how we will reverse a number. I will take the same example. Let's say our number is 1, 2, 3, 4. If I have a variable of num, let's say num as a variable, I am storing this number in it. I cannot assign the new number to this same variable. I need to create a new variable. So this was basically num. So I can write uh, that num is equals to, let's say, 1, 2, 3, 4. So after creating the variable as num, which is storing 1, 2, 3, 4, let's say I have another number. Uh, let's say it is reverse, and I'm storing 0 in it for now. Okay, so how do I reverse this number? Num equals to 1, 2, 3, 4. What I need to do first, I need to get each and every digit of this particular number. So how do I get this particular digit, each and every digit of this number? The same logic. What I will do is first I will calculate its remainder by 10. I will get a 4. Then what I can do is, after getting this particular digit, I can add this particular digit in this variable. So what will happen is it will become equals to 4. Okay. So after adding this particular digit in this number, I can now divide this number by 10 in the form of integer division. So I get 1, 2, 3. Now I have divided this particular number. Now I also need to do one more thing in my next loop. What will happen is, see, this all things happen in one iteration or one run of the loop. Now in the second run, what I need to do is basically I need to also multiply this uh, reverse variable by 10 so that this reverse becomes 40. It is now 4, it should become 40. So that when I will add another number in it, let's say it is the next number that I will add is 3. So it will become 43 when I will add it. Otherwise, it will become 4 plus 3, which is 7. Since we have to do the repetitive thing, I can even multiply the number by 10 over here, because we know that 0 multiplied by 10 is basically 0. So yeah, now what we will do is in the next iteration, I will perform the same thing again. I will get a 3 over here. What I can do is I can make reverse equals to reverse multiplied by 10. So I will get a 40. I can add I can add uh, this particular digit that I got in this. So I will get a 43. Similarly, I can even do the same thing for other digits as well. So I got a 43. So my 34 became 43. That's good. Now what I can do is I can again divide my number 123 by 10. So I will get a 12. Now what will happen is I'm moving uh, to the other iteration. Now in this particular new iteration, what I will do is I can again calculate the digit in this way by calculating its modulus by 10. So I will get 2. I can multiply the previous 43 by 10 so that it becomes 430. So it will become 430. I can add this particular 2 in this 430 so that it becomes 432. So what I will do is I will add this particular 2, the new digit that I got. So it will become 432. In the next step, what I can do is now I can again uh, divide this number by 10. Or basically what I mean to say is I can uh, divide this 12 in the form of an integer division by 10. So I will get 1. In my next iteration, what I can do is I have got my number has become 1. What I can do is I can uh, get 1 as a digit by calculating 1 modulo 10. So I will get the digit as 1. Now I can again multiply the number by 10. So I will get 4320. Now I can add this particular digit in this number, which was 1, which was 1. So my number will become 4321. So now what I can do is I can divide my number 1 in the form of an integer division. So I will get 0. Now I need to stop. So you can see what actually happened. You can see that uh, our initial number was 1234, but it became 4321. So this means our number got reversed. Now I am going to write this code for you. Let's say our number is what I am taking as input from the user. Now I need another variable as reverse, and it will have a value of 0. So we know the numbers reverse will be 0 if the number is 0 itself. So this means even if the number is 0, we are actually storing its reverse, which is 0, in the number. So we do not have to write any new condition for the number 0, for the condition when the number is 0. So there is no need to write a new condition. What I can do is now I will write loop while num is greater than 0. Okay, first I need to get the digit. So digit is actually equals to num modulo 10. Okay, now what I need to do is I need to even multiply the reverse before adding that digit to this particular number reverse. So I will multiply it by 10, and I can even add in the same like this, or instead You can, yeah, you can do that as well. Or what you can do is, that's up to you. Reverse is equals to reverse plus digit. Just for your simplicity and clarity, I'm doing like this. In the next step, I also need to update the number. So what I will do is, I will do num is equals to num integer division by 10. So this was all the things that I needed to do. Now what I can do is, I can, outside this loop, I will print reverse number is equals to reverse. So this is our code. It is not a very lengthy code, it is a small code, but the logic that you need to study is this one. You need to understand this logic. Now, I will be sharing, I will be sharing this particular PDF in the description box of this particular video as well. So do check it out and revise this logic again. Now I'm going to write this particular code. What I will do is, I will create a new file. I will call it reverse a number hw.py. Okay. So what I will do is, I will take num as an input, which is an integer. From the user, I will say enter a number. Then I will write reverse, or I can even write reverse underscore num equals to 0. But since I actually took the number as reverse, I can take it like this as well. So reverse is equals to 0 while num is greater than 0. What I need to do? First I need to get the digit of that particular number. So I will get this digit like this. Then I need to multiply the reverse number or the reverse by 10 before adding this digit to it. Otherwise, we know that 44 plus 3 is 7, but we need to get 43. So 4 should become 40, then we will add 3 to it, so it will become 43. So this is basically the most important logic in this particular question. Then we need to add uh, add the digit in this particular number. Now at the end I also need to update the original number. So now I can print reverse number is equals to reverse. Now I am running this particular program. Let's say our number is 0. So you can see reverse number is equals to 0. Let's say my number was 1234. You can see the output is reverse number is equals to 4321. Let me take the third example where the number is 12045. You can see my number became 54021. So this was our homework question second. Now we are going to study the topic for today, which are loop control statements. And the most important loop control statements are two of them, which will be used the most. First one is break. The second one is continue. Now there are two more things which are pass and else as well. So we will learn them also. But first, let's start with break. Break. So what is break? You know that it's a keyword in Python. What does it do in a loop? So let's take a particular example or a situation. Suppose I want that my loop is running. At this that particular time, suppose I want that my loop should exit earlier than the final terminating value. Or what I mean to say is, suppose I wanted my loop to run from 1 to 10, but under some circumstances, I want to stop my this loop at the value of, let's say, 7. In this particular scenario, I need a break. So break is basically a keyword which is used in loops. It can be a for loop, a while loop, nested loops as well. So what break actually does is it terminates the loop containing the break statement immediately. Now what I mean to say is break actually exits the loop early. Okay, and this is regarding single loops. What I mean to say is, let's say they are not nested. Uh, one loop is not containing the another loop, which means you can say that, yeah, basically there's one loop and you might have certain conditions within it or certain code within it. So in that case, break statement will exit that loop early before it should exit naturally. We can also use the break in the nested loops as well. So what actually break does in nested loop is it immediately terminates the closest enclosing loop and transfers control to the statement following the loop. So even in the case of nested loops, it is basically doing the same thing. It is used when we want to exit a particular loop early. But let's say one loop is inside another loop. So this is called the nested loops. Let's say my break statement was inside the inner loop. This means if break is inside the inner loop, it will not terminate the outer loop. It will terminate the inner loop. So if there is for I in range and something uh, like a start, end, and step, not step, basically the step, then there is another loop inside it for j in range, start, and step, and this j loop is actually containing the break statement. The I loop will not get terminated because of this. So what I meant to say is break statement actually terminates the loop containing it. The loop which is enclosing the break statement will get terminated and not the outer loop. Let me give you certain examples. Let's say the example is I am writing certain code over here for I in range. I am going from 1 to 6, and then I'm writing if I is equals to, let's say, uh, 4, I am saying break. Okay, so this is a particular code. Let's see the situation. So I have written for I in range 1 comma 6. So this means the loop will start from 1 and it will go up to 5, not 6, because 6 is excluded. So then I have written inside the loop if if I is equals to 4, break. Otherwise, what you can do is print I. So let's see what will be the output of this particular code. I will write the output over here. Hmm. Let's take a particular scenario when this particular if statement uh, if statement was not there. What would happen? I will get different values in the range from 1 to 5. So I will become 1, 2, 3, 4, and 5. Each time the loop will be run, I will get I will get different values starting from 1 till 5. These values will also get printed. So I will get a value of 1, 2, 3, 5. This was naturally what should have happened. But in this certain scenario, uh, this is the case in which uh, there was no break statement. Now let's say uh, I have the break statement. So I'm writing this particular code again, the same code for I in range 1 comma 6. If I is equals to 4, I am breaking the loop. Otherwise, uh, I am printing I. So what will be the output in this case? Let's see the difference. Now what will happen is I might get different values. So I should have got 1, 2, 3, 4, 5, these values. So when I will be 1, we know that this particular condition will not be true. So this break statement will not get executed. But this print statement, which is outside the condition, will get executed. So I will get an output of 1. Now the next time when I becomes 2, we know that again this particular uh, if condition that I must be equal to 4 will be false. So this break statement again does not get executed. Now again we know that this print statement is outside this particular if condition. So 2 will get printed. Now I will move to 3. I know that 3 is not equals to 4. This means this particular break statement will not get executed. But this print statement will get executed. So I will get a value of 3 in the output as well. Now my value of I is 4. So now what will happen is, let's see, uh, this particular condition will be true because I is actually equals to 4. So in this particular case, I will actually become, since I is 4, this break statement will get executed, and we have studied that it is used to exit the loop early. So what will happen is we will get out of this loop, so this print statement will not get executed for any value after this 4. So this loop is basically terminated. So this will be our output. This is this was that will happen. Now I am also going to code this particular example in the VS Code to show you that how what actually happens. Let's say the file name is break example1.py. In the first scenario, when I am not using the break. Uh, so in this scenario, you can see that I am not using the break. So now I am running the code, and I expect that 1 to 5, all the numbers should get printed. So you can see that 1, 2, 3, 4, and 5 got printed. Now what I am doing is, before this print statement, I am writing a certain condition. If I is equals to 4, I want to print. What will happen is, now I am running the code. You can see that 1, 2, and 3 got printed. So this happens because when my I became 4, this particular condition was true. So break statement got executed and my loop terminated. Now let me take another example in which basically I want to print the tables of certain numbers. Uh, what I mean to say is I'm taking the example of nested loops. Let's say I'm saying for I in range 5 till 16 and my step is 5. Then I'm writing for j in range, let's say starting from 1 till 11, I want to print I, comma, multiplied by j is equals to I multiplied by j. So this is the code that I want to write, but I am saying if j is equals to 3, I am saying break. Now outside this particular for loop, also I am writing if I is equals to 15, I am saying uh, I is equals to 10, I am saying break. So let's see what will happen in this particular program. Now let me take a certain scenario when there was no break statement over here, and over here, there was no break statement. So from our previous session, I gave this particular question as example also. So what basically will happen is, I will get uh, uh, the tables of 5, 10, and 15 written over there. Yeah, there was one more thing that I forgot to write. I have to also write just print over here so that there can be one line space uh, after each table if I is equals to 10. I want to break. Okay, so if there was no such, let's say, no such statements, what should have happened? We know that the tables of 5, 10, and 15 should have got printed. So I must have got 5 ones are 5, 5 twos are 10, and so on. Then one line space. Then 10 ones are 10, 10 twos are 20, and so on. Then one line space, and then the table of 15. Complete tables. But since we are using uh, the break statement, this is not what will happen in this scenario. So what will basically happen is, let's see. First I am taking the values of 5, which will be 5, 10, and 15. Okay, so for each value of I, which is 5, 10, and 15, I will get J as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this means let's start when I is actually 5. So when I is 5, we are starting with j equals to 1. So when j is 1, I am printing 5 ones are 5. Then I am checking, is j equals to 3? The answer is no. So I am not breaking the statement. Now again I am going back. My j will become 2. So now I am printing 5 twos are 10. Now again I will, after printing, I will check, is my j equals to 3? The answer is no, it is actually equals to 2. So my break statement will not get executed. Again I will go back and I will check uh, over here. I will see that, hey, is my j 3? Before that checking, I will print 5 threes are 15. Then I will check, is my j equals to 3? The answer is true. So this particular uh, break statement will get executed. So what will happen is, this loop containing the break statement will be terminated. So no values from 4 to 5, 4 to 10 will get uh, will actually be uh, stored as j. Or what I mean to say is, j will actually not run, or this inner loop will not run for any of these values. Now what will happen is, we have actually terminated from the inner loop, but our outer loop will still run. So what will happen is, I will go to print statement. This means I will get a one line space over here. Then I will check, is my I equals to 10? The answer is no, because our I is actually equals to 5. So this break statement will not get executed. Now I will start this outer loop again. My value will be 10. So what will happen is, now again I will start my inner loop starting from 1 till 10. Again I will check this particular, I will again print the value of the table, or basically the table of 10, like this. Till 10 is 10 3 is a 30. So when I will become 3, 10 3 is a 30 will get printed. Then we will check that j is actually equals to 3. So this break statement will get executed, and this print statement will actually create a one line space over here. Then I will check, is my I equals to 10? The answer is yes. In that case, my break statement will get executed, and I will get outside this outer loop as well. So this will be my output. Now I'm going to run this particular program in the VS Code. So I have coded this particular example, the same thing over here. And now I'm going to run this particular code. So you can see we have got the same output. 5 stable till 3 and 10 stable 3 till 3. So this was all about the break statement. Now we will go to our next topic, which is continue statement. So now we are going to discuss the continue. So what exactly is continue? Suppose that instead of terminating the loop, you just want to skip certain part of your loop. In that case, you can use continue statement. So what I mean to say is, let's say there was some loop, and at certain value you want to skip that loop. So you can use the continue. So what exactly the continue does? Continue skips the rest of the code inside the current loop iteration and proceeds directly to the next iteration of the loop. And when is it useful? So it is useful when we want to ignore certain cases but still continue looping. So this is the definition of continue statement, or basically what exactly it does and when it is useful. So now I am going to also give you certain examples of how continue statement is really helpful. So in short, I can also write continue skips the current iteration. Or if you have written continue somewhere, let's say in certain condition, and that continue condition becomes true. So anything written under that particular condition within the loop, same loop, will actually get ignored. So continue skips the current iteration. You will understand it better with certain examples. So let me give you certain examples. My first example is, let's say I'm writing for I in range 1 to 6. I have written if I is equals to 3, continue, and outside this if statement, if block, or yeah, basically this if statement has certain block of code which is only continue. So outside that I'm writing print I. So if I is equals to 3 continue was not there, we all know that 1, 2, 3, 4, and 5 should have got printed. But let's see what will happen in this particular case. So this is our output. See, first I will become 1. You know that I is actually uh, equals to 1. So this condition will be false. So this continue will not get executed. So, and then this particular print statement will get executed. So I will get an output of 1. Then moving on, I will become 2. This particular condition will be false. So this continue will not get executed, but this print statement will get executed. So I will get 2. In the next iteration, I becomes 3. You know that this particular condition is true now because I is actually equals to 3. So this continue will get executed. Now what will happen is, since this continue gets executed, anything written below this will get ignored and Python will move to the next value, which is 4. So what will happen is basically 3 will not get printed over here. Now moving to 4, you know that 4 is not equals to 3. So this condition will not be equals to true. So this continue will not get executed and you will get output as 4. Now the value of I will be 5. So when I will be equals to 5, you know that this particular condition will not be true. So this continue will not get executed and 5 will get printed. So this is what will exactly happen. This is how continue is used to skip the current iteration or basically ignore the other part of other code which is written below it in certain condition. Now I will give you a similar example, just a small difference is there. Now I am writing, uh, this is another example. You will understand by this example why the placement of continue or break statement or any such loop controlling statement, basically jump statements, placement or what I mean to say, where they are actually placed, creates a difference on the output. So let's see. For I in range 1 to 6, print I. So in this case, first I am printing rather than checking whether I is equals to 3 or not. Print I. Then I am saying if I is equals to 3, continue. And there can be, yeah, basically this. So you will understand even more about the continue statement from here. This will be our output. Uh, This is our output. So first I will be 1. I will get printed. So your output will be 1. Is I is equals to 3? The answer is false. So continue will not get executed. Then I will become 2. You will print 2. This condition is false. So this will never get executed. Then I will get a value of 3. 3 will get printed. Since this particular condition is now true, so continue will actually get executed now. But you know that nothing is written below this continue. So now what will happen is, even if there was certain part of code written under it, that would have got basically skipped. But in this case, what will happen is Python will now move to the next value, which is 4. So what will happen is, now I will become 4. It will get printed. This particular condition will be false and continue will not get executed. Then I will become 5. 5 will get printed. This particular condition will be false. This basically this continue will not get executed. So this is what actually is happening. And in this case, uh, continue actually worked. It worked, but since nothing was written below it, so there was no code which was actually skipped. Now I'm also going to code these examples for you in the VS Code. So this is continue example 1. So I'm going to write for I in range 1 to 6, if I is equals to 3, continue. Otherwise, you can even, yeah, you can print the value of I. This was our first example. You can see 1, 2, 4, 5 got printed. But now what I will do is I will just change the placement of this particular code. Or yeah, basically I will do the same thing. I will just change certain things in this code. I will just interchange the positions of the if statement and the print statement. So I will first print, then I will check the condition. Now we know that even though continue actually worked when I was equals to 3, but there was no block of code below it or below the if condition to actually get ignored. So what happened is that I directly became equals to 4 the next time. So I should get an output of 1, 2, 3, 4, and 5. So you can see that I got an output of 1, 2, 3, 4, and 5. So this was all about the continue statement. Now moving to the pass statement. This is a very easy statement in Python. So what basically it does is, suppose you wanted to write, you basically under certain conditions, or what I mean to say is in some loop or under certain situation, you do not want to give any block of code over there. Over, let's say, in certain, let's say, loop, or in certain if else statement, you did not want to give any code. So actually Python may give syntax error if you will leave that particular space empty. But to basically avoid this syntax error, this pass statement is used. It basically acts as a placeholder. What I mean to say is, now I will also write down. So pass statement in Python, the pass statement in Python is a no operation statement. What I mean to say is that it does not perform any operation. So it does not do anything, means it does not perform any operation. It only acts as a placeholder. So it is used as a place holder. Where where is it used? So why are we using the past statement as a placeholder? Suppose there was certain place where certain block of code should have been there, but to avoid, uh, but if we do not want to give any block of code over there, or we are planning to give the block of code later, still we want to run the program without giving any syntax error, we can use this placeholder called pass. So where is it used as a placeholder? It is used where syntactically, means as per the syntax of Python, syntactically, 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 some code is actually required, but we do not want to execute anything. So pass statement is very easy. Uh, there is not much about it. I can give you a certain example over there as well. For example, I write for I in range 1 to 6. Now I say if I modulo 2 is equals to 0, pass, else print odd. So you can see in this case, what I am doing is basically what I wanted to do is in the case when the number was starting from 1 till 5, if any number was odd, I want to display odd to the user. But if it was even, so I do not want anything to be displayed to the user. But since I have written a condition that I modulo 2 is actually equals to 0, I cannot leave that particular block of code empty. So I need to give anything such as a placeholder so that Python does not give any syntax error. So I just write pass. You when you will study functions, and yeah, functions you will study, in that you can also use pass to uh, basically leave certain function empty. So when we will study that functions in our future sessions, I will explain you that there as well. But you can see that what will happen over here is basically see what will happen over here is when I is 1, odd will be displayed. When I is 2, nothing will get displayed. When I is 3, odd will get displayed. When I is 4, nothing will get displayed because pass is written over there. When I is 5, odd will get displayed. So now I'm going to code this particular example for you as well. So I'm naming the file as pass example 1.py. I'm writing for I in range 1 comma 6 if I modulo 2 is actually equals to 0. I am just writing pass, else I am printing odd. Now I am running this particular code. You can see odd will get printed 3 times for 1, 3 and 5. But for 2 and 4, we have used the pass placeholder and nothing will get actually executed. Now there is one more thing. Let me which I am giving you as an example. Let's say pass example 2.py. Suppose I uh, it is not only the conditional statements in which pass can be used. You can even leave a function or rather a loop empty as well. So suppose write for I in range 1 comma 6. Now you can see that from the starting it has giving started giving some red symbols or the text has become red. So if I will run it over here, you can see it will give a syntax error. So it has given a indentation error because Python actually uh, expected certain thing over here, but I write pass over here. So you can see that my code will run without any error. Although I have not printed anything over here, but it will not give me any error. So this is just a placeholder. Yeah, but even if I along with the pass, I write something like I print I. Let's say print I within this. So it will not give me an error, and both pass and the print statements will get executed. So what I mean to say is pass is just a placeholder. It is not anything more than that. Now I'm going to move to else. Now we have studied the else in the case of if elif else means which means the conditional statements in Python. But this particular else is basically the else clause which is a little bit different from that. Uh, Now we are going to discuss that. Okay. So now we have to discuss the uh, else. So suppose there was some loop, let's say a for loop or a while loop that does not actually matter, and you give certain condition in it, and in that condition you wrote break. Now let's take first situation in which that particular block of code was basically what I want to say is that particular loop started and ended naturally. Means that particular break statement did not terminate the loop by itself. So in that case, what happens is this else block will be outside that particular loop. It will also have certain code, and that code will be executed. But in let's take certain another condition in which this break statement actually got executed. So in that case, this else condition, else clause will have certain code. That code will not get executed. What I mean to say, if you want to decide that there was one loop, if it gets uh, terminated naturally by itself without the break statement causing it to terminate, you can use an else clause and that particular block of code will get executed. But if it does not get terminated by itself, it got terminated because of the break statement, then the code within the else clause will not get executed. So if that code of block of code, you want that block of code to get executed only when that particular loop terminates naturally, you can place that block of code within the else statement. So how do I write this? Let's see. An else block after a loop is executed is executed only if loop completes naturally or normally. Completes normally. That is, it is not terminated by, it is not terminated by break. So if there is no break statement in your particular loop, you are 100% sure that if you have written else clause after that loop and you have written certain code block of code, it will always get executed in such case. Now I'm going to give you certain example regarding this else clause so you can understand it more better. So the example now that I'm giving you is, let's say I'm writing uh, first example for I in range 5. So my loop is starting from 0, it is ending till 4, and this cap is 1. I am writing print I, and then I'm writing else outside this loop print loop completed successfully. Now let's see what will be the output in this case. So this is our output. We know that what will happen is I loop will start from 0, that will go to 1, 2, 3, and 4. So these values will get printed 0, 1, 2, 3, 4. Then, since there is no break statement in this loop, or this loop got executed normally, this particular else statement will actually get executed. So what will happen is anything written or any block of code written inside it will get executed. So the output will be loop completed successfully. This will be your output. Now let's take a similar example, just a small change in it. Let's say I am saying for I in range 5, if I is equals to 3, break, then I am also printing the value of I, and I am also writing an else clause, and within it I am saying print, let's say loop completed successfully. Now let us see what will be the output in this particular case. So this will be our output. So values of I will be from 0 till 4, 0, 1, 2, 3, and 4. When I will be 0, this particular condition will be false. So no break statement will get executed. So 0 will get printed. Now next time I will be 1, this condition will be false. Break statement will not get executed. 1 will get printed. Next time I will be 2. So this condition will be false. Break statement will not get executed. So this print statement will get executed. Next time I will be 3. So this particular condition will be true. Break statement will actually get executed. So loop will actually get terminated forcefully. So this print statement will not get executed for I equals to 3. So what will happen is loop will get terminated completely. So the values 3 will not get printed and I will not move to the value 4. So 3 will also not get printed. Since the loop did not complete naturally, it got terminated forcefully using the break statement, this else clause will never get executed. So this print statement will never get executed. So your output will be 0, 1, 2, 3. 0, 1 and 2 only. So this was all about uh, the else clause as well. Now we are going to code these examples. First example I am going to code is else example 1 dot py. Suppose I write for I in range 5 print I, and outside this loop I am writing else print loop completed successfully. Now I am going to run this code. So what will happen? Let's see. You can see 0, 1, 2, 3, 4 got printed, and this particular else clause also has a print statement that also got executed. So loop completed successfully also got printed. So this is our output. Now I am going to write the same code but with a minor twist in it. So I am creating a new file else example2.py. The code is similar. Just before printing, I am checking if I is equals to 3. I am breaking. So let's see what will be our output. As per our intuition, the output should actually be 0, 1 and 2. So let's see. You can say 0, 1 and 2 got printed. So this actually never got executed. So this was all about the uh, else clause as well. So today's session is basically over. Now before ending this session, I have one homework question for you. Although it is not related to loops or the jump statements that we studied today, but this is a good question. So using the conditional statements, so I want you to solve this question. The question is, check whether a given year is a leap year or not. So you have to take basically a year as an input from the user, and you have to display whether it is a leap year or not. So 1900 is not a leap year. 2000 is basically a leap year. 2020 is a leap year. 2023 is a leap year, is not a leap year, and 2024 is a leap year. So please read the definition of leap year. Most people only think that leap years are basically the years which are divisible by 4, but there are more points to it as well. So read the definition of leap year and then try to solve this particular question. And if you are able to solve this particular question as per these examples also correctly, do comment its answer in the comment box. And also I will also be solving this question in our next session. So that's all for today. If you learned something new today, please like, share and subscribe to my channel. See you in the next video. Thank you.